Welcome back to the channel, and then just try to do some more Leetcode today. Um, Today we're solving an easy question: rank transform of an array. I do mention that I have a mic yesterday, but it kind of like hard for me to plug it in my MacBook. I can like do audio on my iPad and then edit the video later on, but it's just a lot of work. So I might try to get a new adapter that possibly that I can plug in the mic thing and then make it works for two screen. Because right now, if I set this to be like a second screen, and then it wouldn't have like distracting like the bar. But anyways, so let's look at this question. So we're given an array, and then we want to replace each element, which is rank. So the rank represents how large the element is, and then the rank, it's the larger the element, the larger the rank. And then if two elements are equal, the rank must be the same. So if you have like 100, 100, 100, it's all equals to 1. But you have like 101, the rank will be 2 instead of like 3 or something, because we don't really care about that. We just want to like increment it by 1 at a time. So it's possible that you have multiple same rank, and then the next one is just plus 1 instead of plus how many you have already. All right. So rank should be as small as possible, right? Okay, so the first thing that comes to your mind is how do you actually know who is the smallest one, who is the second smallest one, and then go up the way, right? So one way you can think about it is you can actually sort the array, right? You can keep a copy of a sorted array, and then you match that number to the rank, right? So let's see if I can get a PowerPoint here. All right. So let's say you have 40, 10, 30, and 20, right? Let's say I forgot the exact same one, but if you keep a sorted array, it will be 10, 20, 30, and 40, right? So right now, if you set a map, where key is 10, and then you map it to be 1, and then 20 to be 2, 30 to be 3, and 40 to be 4, right? And then you can get back here, and then you already have this map, right? So when you go back here, and then you see this is 40, right? This is 40. So you can just replace 40 to be 4, to be the key, which is the rank. And how about 10? And if you're 10, then this will be 1, and then 30 will be 3, and then 20 will be 2. Right? You're just replacing them and then return it. What is something that you need to think about that might mess up your case here when you try to do the sorting, right? Or you want trying to do the map, right? One possible case is when you have similar like things, right? When you sort an array is like 10, 10, 10, then 20, and then 30, right? So when do you know you want to increase the rank, right? So the first time you see something, of course the rank will be 1, right? But when you have the same thing, you kind of just ignore it, right? You just kind of ignore it. So every time you go to the second element, like or the next element, you just want to look back. If there's the same, then you don't increment the rank, and then you don't care about adding it to the map because your map already have this key. And then you just look at the next one, and then you're like, hey, how about you, right? And then look backward, and it's like, oh, actually, I also already done this one. This is the same, right? When you look at 20 and then you look backward, it's like, oh, actually, this is a different thing, right? So I want to go in the map, put this key, and then increment the rank by 1. And then 30, right? That's how you do it. So I think we're actually kind of good right here already. So the concept is having a map, and then having a copy of sorted array, right? A sorted array. So let's just code it out. So let's start a timer. All right. So we can get a sorted array copy. Why do we use sorted instead of array.sort? So array.sort actually sorted array, but sorted array is making like a copy of this sorted array, and then the array itself is actually not like, it doesn't change the original array. All right. And then next step is we have a map, and then we can say count equals to 1. The count's whatever stands for rank, right? So for I in range length of sorted array. So people do it in different way, but I like to think about it as like if I is the first element, then no matter what, your map is gonna be the element and the count is equals to 1, right? The count already equals to 1. So you want to set that equals count. So map of the key in the sorted array is just gonna be equals to count. And then you want to increment count by 1. No matter what, you increment count by 1. Why is this case, right? Why increment this anyway, right? So thinking about this, right? If we see this one, we see the same element as before, right? That we don't actually put it in the map anyway. So since the count is now 2, we don't care, right? We don't actually put 2 to this. We actually skip this one, and then we skip this one, right? So since we actually gotta skip them anyway, so we don't care. But the other case is where if, okay, I can say continue, so means that we don't need to look at the rest anymore, because you're done, basically you're done with the case where the first index is that. So the other case is where you have the second one, or like I greater than 0, and the thing before them is different, right? So you can guarantee this will be I greater than 0 anyways, because this case will return. So if I is greater than 0, means that you have a previous element to check, right? So you can say your current element is not equals to, or you can say greater than, because you know it's a sorted array, doesn't matter. The previous element, if it's not equal, right? Then now you have a new value along this case. This is like the 20 case, right? Your rank is already 20, your count is already 2, and then you find 20, which is like different than the before one, right? You now find this one, your count is already 2, so you found that, oh, this one is actually not the same as 10, right? So here you do the same thing, equals to count, and then you increase count by 1. So there are a lot of ways actually to do this. Like people like to maybe combine, like if I greater than 0, and then so the array I not equals to this, then you do count plus 1, and then you, at the general case, you want to like set that to be equals to count. It also worked. So what I'm saying is you're having this, oh shoot, you're having if I greater than 0 and sorted array at this part. And then you increment count by 1. And then at the very end, you do this. So it actually depends on how you want to do it. But the first case is like, it's easier for me to understand and easier for me to explain to people. And then this part you can reason it through by yourself, right? So first time here, you wouldn't get in here. So the first element will be always equals to 1. And then the next time you want to check if this is greater than 0, and it means that you have the previous element to check and they're not the same, then you increase the count by 1 and then you do the count. So this is like, you don't, let's say you have same thing, right? Your count is always 1 until you meet the other one. You only increase it and then put it into the map. My first approach is you always increment it and then you ignore this case. And then there's always 2, and then 2 is hit to the next one, and then you put it into it. Right. Okay. So anyways, this is just the processing part for the map for hashing, right? And then we're going into actually changing like this, right? So you can either set a new array to be result and then append it. So you can set result equals to empty array, and then for num in the array. Now for every number in the original array, you can just look it up what happened right there, right? It's just append mat.getNum, right? But the other way of doing it, right, is actually you don't need an additional data structure like array right here, right? You can just use the original array and modify it, right? So you can say for num in array, but in this case it doesn't really work. So you want to say like for I in range length of array, right? Then you can just change array I equals to map.get array I. So this is the value. You want to replace the value to whatever your array is, and then you can just return the array. Right, I am just want to make sure that I didn't do anything wrong. So this part, I leave a comment here. So if you really like this, if it's this clear for you. All right, I'll run this and then let's submit this. All right, so the runtime is actually just the sorting part is of n log n. This part is of n because you go through once and then you go through another one. So say it's like of n plus of n plus of n log n. So the overall runtime is of n log n, and then yeah. So the space complexity is we have an extra map data set that should be just of n. So this is the space and runtime complexity. So I hope this video helped, and I'll see you in the next video.